In 1945, Germany and Japan signed surrender documents marking the end of World War II. One of the pending issues of the war was how to get rid of excess munition. One solution at that time was to simply dump them into the Baltic Sea. At least 50,000 tons of chemical weapons were dumped into the Baltic Sea, mainly at a depth of 70 to 150 meters. The dump sites include Bornholm Basins, Gotland Basins, Southeast Scotland Basins, Skagerrak, and the Little Bight. Dumped munitions are mainly explosives containing TNT and chemical weapons such as sarin, mustard gas, arsenic-containing poisons packed in metal shells or simple barrels. To understand this problem, we have to look at the basic anatomy of the ecosystem structure, which could be divided into two parts, the abiotic and the abiotic. The abiotic is the part that comprises of what we call the producers, consumers, and decomposers. Let's look at the abiotic part of the marine ecosystem first. First of all, shells of these munitions are poisoning sources. Most of these shells contain arsenic and mercury, which are toxic chemical species. During the corrosion process, arsenic and mercury gradually form soluble compounds and dissolve into the sea. The corrosion process happens on the weapon shells, releasing chemicals inside the weapons. Although the impact of TNT and viscous mustard gas on water quality is relatively mild because of their low solubility, they can change the composition of seafloor sediments. Sarin and hydrolysis products form a toxic cocktail of degradation products near the dump site. Heavy metal compounds contained in the munitions are also released. Together with the heavy metal dissolved during the corrosion process, they cause severe pollution. In the case of arsenic, a project in 2004 revealed that its concentration in the dump site sediments is 9.7 milligrams per kilograms, over 4 times higher than the average. Then how does this impact the marine life in the ecosystem? Recall our anatomy of the ecosystems. A major producer of the Baltic Sea, plankton, might be responding to munition pollution negatively. A study suggested that dumped munitions interfere with the photosynthesis process. Concerning consumers, lower biodiversity has been observed. A study done across various stations in the Baltic Sea in 1980s found 10 microbenthos species inside 78 to 110 meter depth of the sea, including stations near the dump sites. However, in 2013, while the numbers maintained in the other stations, only 3 species were found in the samples taken from stations near the dump sites. There has been increased fish mutation on a cellular level around the dump sites near the Latvian shore, much like the process of humans developing cancer. And this is not the only case. Near northern Germany, common dab, a flatfish whose main habitat is on the seafloor, has a tumor rate of 25%, astonishingly higher than the 5% in 3 other Baltic Sea areas investigated. Scientists believe this is due to the sediment pollution by the dump munitions. Decomposers are also affected. In the dump sites, microbial biodiversity is decreased, with increased growth of a handful of species that can utilize the hydrolysis product of mustard gas. In the southern Baltic Sea, 15 species of bacteria are found outside the Bornholm dump site. However, only 3 are found at the dump site. We have seen the impact of dump munitions on marine ecolife system, on various levels and aspects. Luckily, more and more organizations are investigating this problem. We hope that by understanding the problem, we will avoid repeating this history.